This is Dr. Shankaraiah from Department of Physics. In today's presentation, I am going to discuss about topic from nanotechnology, which is module 5. So the topic of the presentation is fabrication of nanomaterials or nanoparticles. And once I discuss about this fabrication method, I will discuss about ball milling method. Okay, so the two basic approaches used in the fabrication of nanomaterials are top-down approach and bottom-up approach. So to fabricate these nanomaterials or nanoparticles, we have two approaches. Okay, so the first one is top-down approach and bottom-up approach. Okay, so what do you mean by top-down and bottom-up approaches? So these are the two basic approaches to fabricate nanomaterials or nanoparticles. Okay, so what is bottom-up approach? In this approach, atoms or molecules or particles, nanoparticles are used as building blocks for the creation of complex nanostructures or nanomaterials. So in bottom-up approach, bottom-up, so from bottom we are going to up. Okay, so we are in the bottom, we always have, so this, if we think of this as a length scale, so here we have small lengths. So if we think of this, the direction going up is length scale, increasing length scale. So here we have small length scale, that means nanoparticles. In bottom we always have nanoparticles, and now we are going to use these nanoparticles to fabricate nanomaterials or nanostructures. Okay, so in bottom up approach, basically we are going to use atoms or molecules or nanoparticles. So small size, small length scale, small size particles or atoms or molecules are used to fabricate large scale nanomaterials or nanostructures. So this is what is called bottom up approach. Okay, so what is top down approach? Yeah, so yeah, we will discuss about this in detail. So these processes are highly controlled complex chemical synthesis techniques. Okay, so bottom up approach is basically bottom up. In bottom up approach, we are going to use nanoparticles or atoms or nanoparticles or molecules. We are using many of them, we are going to group them together to fabricate clusters and hence nanomaterials or nanoparticles. Also we can fabricate using atoms, or we can use nanoparticles to fabricate nanomaterials or nanostructures, right? So these are highly controlled process and complex chemical synthesis technique. Okay, so these are mostly highly controlled and chemical synthesis techniques. In this approach, materials and devices are built from molecular components which assemble themselves chemically by principles of molecular recognition. Okay, so when we take many atoms together, they will all group together. How they will all group together to form a cluster, to form a material, right? So how do they group together to form a particular nanomaterial? For example, if we are taking nanoparticles to fabricate a nanomaterial, so how are they going to set up or sit in proper places to give us a material? So this is because of the principles of molecular recognition. Okay, because of the chemical principle, they will sit up in regular places and to give us the particular material. Okay, so this is bottom up approach. So in this bottom up approach, they seek to arrange small components into more complex assemblies. Nanoscale structures are normally achieved by chemical synthesis of materials in liquid or gaseous phase. Okay, so these when we are saying that bottom up approach, small scale particles or atoms are going to group together into complex nanomaterials because of principles of chemistry or molecular recognition, and these nanoscale structures are normally achieved by chemical synthesis of materials in liquid or gaseous state. We can achieve this, we can fabricate these nanomaterials using atoms or molecules when they are in liquid or gaseous state. Okay. Yeah. So this is about bottom up approach. Okay. Bottom up approach. So basically, we are going to use atoms are molecules or nanoparticles. If you use small length scale, small size atoms, molecules or nanoparticles to fabricate larger scale assemblies or complex nanostructures and nanomaterial, right? So nanomaterial, for example, if I am using nanoparticles, I am going to fabricate a nanomaterial using this bottom up approach, where I use um, where I use these atoms in their liquid or gaseous state. So that is about bottom up approach. So the next fabrication method is top down approach. Okay. So in this approach, one rely on either division or removal of a bulk material to produce the desired nanostructures and nanoparticles with the desired properties. So in top down approach, so we are going from top to down. Okay. So as we discussed earlier, if this is the increasing direction of length scale, so we are now in the top, so we are having bulk material. Okay. So we are going to we are going to divide these bulk material into smaller particles. So from bulk, always we have bulk material in the top, and we are going to generate nanoparticles, for example, which are small in length, scale or size. Okay. So in top down approach, we are going to divide this bulk material into to produce desired nanostructures or nanoparticles with the desired properties. So that is what is top down approach. Okay. So top down approach, we are going to divide the bulk material into small particles which are nanoparticles, or you can divide the bulk material into complex nanostructures with desired properties. So that is very important. So these are inherently much simpler process, top down, right? So top down is much simpler than bottom up. Okay. So these are inherently much simpler process when compared with bottom up approach. Okay. So here, so this is, I have here a bulk material, and I am going to divide this bulk material into powder, and then I can get nanoparticles using this top down approach. So in this approach, nano objects are constructed from larger entities without atomic level control. So there is no control here, and we can construct these nano objects using this top down approach. So these two seek to create smaller devices by using larger ones to direct their assembly. So in this top-down approach, these seek to create smaller devices or smaller particles by using larger ones to direct their assembly. So top-down processes of preparing nanoparticles are effectively examples of solid-state processing of materials. So these top-down processes are used to fabricate nanomaterials that are being used in most of the nanotechnology and research on nanomaterials. Okay. So bulk is divided into, first you can divide that into powder, and then that powder can also again divide into small size nanoparticles. Okay. So we have discussed about two fabrication methods of nanomaterials or nanoparticles. So that one is top down and bottom up approaches. Next, we are going to discuss about top down fabrication methods. So what are the fabrication methods that are available in top down approach? So in this top down approach, we discuss three methods that are used for the fabrication of nanoparticles from bulk materials. So we know that top down, we are going from top to down. Always top we have materials, bulk material. We have a bulk material. And this bulk material we are going to divide into nanoparticles. Okay, we are going from top to bottom. So always bottom you have small length nano, and you have here macro or micro. Okay. So from nano to micro or micro to nano. So in top down we are going from bulk material to nano material by dividing this bulk material into smaller size particles. So there are three methods in this top-down approach where we can divide this bulk material into small size nanoparticles or nanostructures. So the three methods are ball milling method, physical vapor deposition method, and chemical vapor deposition method. Okay. So these are the three top-down fabrication methods or fabrication approaches to fabricate nanoparticles from bulk materials. So let us see in detail what is this ball milling method and how do we fabricate nanoparticles from this ball milling method. Ball milling method is also called as mechanical crushing. Okay, so ball milling method is also called as mechanical crushing. So yeah, so this is the setup, experimental setup of this ball milling method, where you have this yeah. So in ball milling, small stainless steel balls are made to rotate inside a drum and drop under the influence of gravity onto a small solid present in the drum. Okay, so we have taken a drum, a spherical drum, and then we have kept a stainless steel ball. So these are all stainless steel balls. Okay, so stainless steel balls are present in this drum. So this is the drum. So in this drum we have kept some stainless steel balls, and then we also kept some material. So material will be here actually, right? So wherever so material will be here. In the beginning, you do not have any particles, so you have a bulk material in this rotating drum with stainless steel balls. Now, so these because of the influence of gravity, when this drum rotates, this material will also come here because of the influence of gravity. So the material will be mostly here, right? So the stainless steel balls, they will fall on this material because of the influence of gravity, and these stainless steel balls will crush this material when they fall from here. Suppose when the drum is rotating, these balls will fall from here or here to, they will fall onto this material. So when they fall onto this material, they will crush, the stainless steel balls will crush this material into powder, and as we keep rotating this drum, this powder will also become smaller and smaller nano size particles. Okay. So this we can understand using from the centrifugal force also. Okay, so the solid is broken into nanocrystallite as this drum is rotating for longer times because of the stainless steel balls falling onto this solid bulk material. These bulk material will be crushed because of the force of the stainless steel balls into small nanocrystallites. So that is why this ball milling method is also called as mechanical crushing. So this is the drum which this is the experimental setup. We can see clearly, but what is happening inside here, that is what we have seen here. Okay, so this is the drum. This drum is rotating and there are stainless steel balls inside this drum, and we can keep the bulk material from which we want to prepare nanoparticles. Okay, so because of this drum is rotating and the stainless steel balls will fall onto this bulk material, and hence you will get nanocrystallites. So ball milling can be used to prepare a wide range of elemental and oxide powders. So we can create powders, elemental and oxide powders, using this ball milling method. For example, iron with grain sizes of 10 to 30 nanometers can be formed. Okay, if we can keep bulk iron material inside this drum, and when we start this drum, then because of the stainless steel balls are falling on this iron, so we can see this iron will be crushed into small crystallites around 10 to 30 nanometer size. A variety of intermetallic compounds based in nickel and aluminum can also be formed using this ball milling method. So ball milling method is preferred method for preparing metal oxides. So if we want to prepare any metal oxide powders and all, we can use this ball milling method. Using this ball milling method, we can prepare around 10 to 30 nanometers grain, small nano crystallite, using this ball milling method. So yeah, so these are some of the textbooks and references books which I have used in this presentation. And to summarize, in this presentation, I have discussed about fabrication method, fabrication of nanomaterials and nanoparticle. So fabrication of nanomaterials, and nanoparticles. Okay, so there are two approaches, fabrication approaches. Bottom up approach. Bottom up approach is the first fabrication approach, using which we can prepare bulk material or nanostructures. Now, top down approach. Top down approach. In this top down approach, we can prepare nanoparticles from bulk material. Okay, so we have discussed about this bottom up approach. In bottom up approach, basically we are going from bottom. We are going from bottom to up. So we are going from nanoparticles or atoms or molecules. Nanoparticles or atoms or molecules. We are going to take them or group them together, group many atoms together or group many molecules together to form a material, nanomaterial, for example, or a complex assembly or a material using these nanoparticles, atoms or molecules. Okay, so this is the bottom up approach, which is mostly controlled, and these atoms follow. How do we get these nanomaterials using this bottom approach? Because all these materials follow the principles of molecular recognition, and they will group together to give us a nanomaterial using this bottom up approach. Then we have discussed about top down approach also. So top down approach is much simpler than this bottom up approach, right? So top down approach, in top down approach, so we are going from top to down. So we are going to break a bulk material into nanoparticles or small nanostructures with desired properties. Okay, so yeah, so these top down approaches are much simpler compared to the bottom up approach. And then we have also discussed different methods. What are the different available approaches in top down method? So we have discussed that there are three different approaches. One of them is ball milling, and second one is physical vapor deposition, and third one is chemical vapor deposition. So there are three different methods in top-down approach, and we have discussed about ball milling. In ball milling method, basically we have a rotating drum, and inside this rotating drum we have stainless balls. So this is the drum, and then we have stainless balls in this drum, and we are going to rotate this drum. And because of the influence of gravity, we keep bulk material inside this drum. Because of the influence of gravity, these stainless balls will fall onto this bulk material, and hence they will crush this material into small size particles. So that is why this ball milling is also called as mechanical crushing. Okay, so because these stainless steel balls are going to crush this bulk material into small nanocrystallites or nanoparticles. So this is one of the method, top-down approach method, which we have discussed to prepare nanoparticles. So that is ball milling. So yeah, so ball milling is basically used to prepare metal oxides. You can prepare many powders using this ball milling method, and even you can get around 10 to 30 nanometers size iron grains using this ball milling method. So yeah, so in this presentation I have discussed about some of the fabrication approaches and ball milling method. So in the next presentation I will discuss about the two other methods in top-down approach, that is physical vapor deposition and chemical vapor deposition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.